Hi, my name is Sebastian Barsan, and this is my project on a terraformation exploration. A terraformation exploration is a study that was conducted to create a reliable, efficient, effective, and cheap spacesuit that can withstand Mars's atmospheric conditions. The question when starting this study was, can familiar spacesuits be altered to meet and undergo Mars's harsh climate? But let's back up. Why build a spacesuit? Well, there's tons of floating debris and detrimental bacteria that can cause the astronauts on Mars to develop serious infections or even unknown diseases, not to mention the extreme radiation and freezing cold climate. This can all be resolved with an effective spacesuit. All that's needed is an innovative idea that might save us all one day. Many different materials and methods were analyzed and laid out to retrieve the highest benefits for this new, revolutionary spacesuit. Now, what would this spacesuit need? First, I thought of a way to shield the immense radiation that could affect our astronauts. Due to Mars not having an atmosphere, this spacesuit would need to be able to shield well enough till the astronauts themselves could burn the local fuels on Mars and create a real atmosphere. The following materials were considered options of a way to shield our astronauts: concrete, glass, water, or polyethylene. After reviewing all the pros and cons, polyethylene was decided to be put as an additive layer. The consisting layers of a spacesuit are the cooling garment, the bladder layer, the ripstop layer, the insulation layer made of mylar, the waterproof layer, the fireproof layer, the bulletproof layer, and the outer layer made of multiple kinds of threads. The polyethylene layer was analyzed to be most effective when it was put in between the insulation layers, so respectively it was put there. Secondly, a way was needed to enter and exit the main space hub efficiently without letting the harmful perchlorate salts enter the vicinity. This can be done in two different ways: decontamination or an additional attachment. As shown on the board, the additional attachment was the superior solution and chosen. Then, after more research, the following materials were chosen to create the final product: mesh spandex, plastic tubing, nylon, mylar, polyester, orthofabric, Dacron and Kevlar, glass, steel, magnetic sensors, metal hinges, plastic, and a thin layer of gold to go around the visor. After materials were set, the spacesuit was created. This consists of creating the cooling garment, the main suit, the additive layer of polyethylene, the additive manufacturing of the attachment of the spacesuit, the helmet, and lastly, the main hub attachment itself. Cost, weight, and gravitational force were highly considered when creating the process, as just too much or just too little could be incredibly detrimental. In conclusion, this design was made to the best extent using the resources we have today. The cost is too inflated to be very profitable, as nothing is perfected. If technology develops and our resources increase, then the future can certainly be looked after to create the most effective, efficient, and cheap spacesuit to withstand Mars's atmospheric conditions. Lastly, I'd like to thank my science teacher, Miss Longden, for all her support and guidance throughout the science fair process, and I'd also like to thank the workers trying their best to create these designs and ideas, which provided me with all the knowledge and information I needed to create this project. Thank you.